Hello, my name is Matthew Wilson, and this is our introduction to adders. So what is the purpose? Today we'll be covering three different types of adders that we'll use in Logisim. And basically these adders are just building blocks that we'll use in order to create bigger circuits later down in the course. And then today we'll be covering half adders, full adders, 4-bit adders, and we'll be testing those as well. The first question is, what is a half adder? And it's basically just a process of adding two bits together. And this is especially useful when you're on the rightmost column of addition, where you're not introduced to using any carry in values. And then a half adder can also be represented by exclusive OR logic as well, as you can see here. Second one is a full adder, and this is representative of the addition of 3 bits. And this is useful because any column of longhand division uses 3 bits. And this is where we go ahead and be introduced to our variable of Cin. And this is just a carry in from the previous column of addition. So seeing like if we had 1 and 1 added together, the sum would be 0, but we would get a carry in value of 1, which we will then use on our next column of addition. Which leads us to our testing here. So starting off first, we have our half adder, which you saw in the example on the slides. And this is pretty straightforward. To go ahead and test this, we're just going to go ahead and use that selection tool here, the poke tool you could call it as well, and just start off by putting in your information. So if we thought of this like an addition problem, 0, 0 will have a sum of 0 and a carry of 0 as well. 1 and 0 is going to have a sum of 1 and a carry of 0. It doesn't matter which order you put these on. It's the exact same result. And then highlighting both of them here, 1 and 1 is going to give you a sum of 0 with a carry weight of 1. Moving on, we have our full adder here. And as you can see, this is just created by using 2 half adder circuits. And a neat trick that you can do is right click and just view half adder, and it'll go ahead and kind of bring you inside our custom designed circuit and show you what's going on in the inside. And then same thing here to check, although now we can introduce our carry in variable depending on which column of addition we are doing. So the values stay the same. As you know, we have 0 and 0, sum 0, C out of 0, 0, 1 is going to give us a sum of 1 and a C out of 0, and 1 and 1 is going to give us a sum of 0 with a C out of 1. And then if we wanted to, we can go ahead and add in that C in, which would just give us 0, 0, 1, so that'll give us a sum of 1 and a C out of 0. And it doesn't matter where you put the 1 here, but 1, 0, 1 will give you a sum of 0 and a C out of 1. And all 3 highlighted is going to give you a sum of 1 as well as a C out of 1. And that's because 1 and 1 is 0, which will give you that C out there, plus an additional 1 will make your sum 1. So a neat feature of Logisim is the use of the hierarchical design. And we can see this by, for example, we'll use our half adder here, just because it's pretty simple and small. If we go ahead and right click and go to edit circuit appearance, you can see it gives us a nice custom circuit that we can build ourselves that we'll be able to use later. As you can see, what we did in the full adder here, we used our half adder circuit, but it's more condensed. Making use of the trick that I showed earlier as well. If you click view half adder, you can see what's going on inside and use it as kind of like a wrapper. You can think of it. That's what kind of helps me think of it. And so once you edit circuit appearance here, it gives you all of your necessary components of your circuit. So you have your inputs A and B, my sum output, and my C output as well. And I basically, again, just made it a wrapper, and I'm able to use it in different circuits as well. So here we have our 4-bit adder circuit. And this one kind of looks a little scary at first. and that may be because it's rotated, but I did this for simplicity's sake because it kind of represents um, like long addition. And so as you can see here, if we took, for example, the sample equation 1101 plus 0110, starting over here with our least, or sorry, starting on the left here with our most significant bit, for our A values, we're going to go ahead and plug in using our poke tool here. We have 1101 and 0110 here, which is going to go ahead and give us the output of, starting from the MSB to the LSB, most significant to least significant, we have 10011, which corrects itself if you go ahead and test that on paper. Again, using the hierarchical design, I went ahead in my adder 4, going to edit circuit appearance, created a circuit that I'm able to use effectively in our testing adder 4 here. So starting, we have our C input, or our C in variable, which we could use, as well as our C out, and then we have values A3 through 0, starting from our most significant bit to our least significant bit, and that follows for our B values as well, and then our sum values, or S values here. And to go ahead and test this, we can just go ahead and use that example problem that we used earlier. So start with the A values here from most significant to least. So we have the 1101 added with 0110, which is going to go ahead and give us our sum output of 1100, the C output of 1, leaving our result as 10011. Without the use of the hierarchical design of Logisim, creating this adder 4 circuit here, or this 4-bit adder, would be incredibly difficult and large, not being able to use those sort of wrappers. And I can kind of show you guys how that would work by starting from the very beginning. So with our half adder here, we were able to create our full adder through the use of 2 of these half adder circuits here. So that then would already kind of look to be kind of a big circuit in and of itself. And for our 4-bit adder circuit, we had to use 4 full adder circuits as well. So that's 4 of these, which would, 4 full adder circuits, which would require 8 half adder circuits within them in order to create this 4-bit adder circuit. So having the hierarchical design in Logisim makes it much simpler to, again, give it that wrapper sort of effect and keep everything nice and condensed for us. And that is all I have. Thank you.